on. Okay. From last time we learned that distance, it can't be a negative number. It doesn't make any sense for distance to be negative. We learned that position, since it's kind of a spot on a grid, it can be negative. So if you move to the left or move to the right, that is important to us. Now, we probably need to come to a conclusion or a consensus right now on which way is positive and which way is negative. Because technically, if I move to the right, then that can either be construed as a positive or a negative number. Or if I move to the left, some people could say, well, that's a positive 2, and other people could say, well, no, that's a negative 2. Okay? Because my right is your left. So I'm raising my right hand, right? But it's on your left side. Okay? So it's all relative when it comes to position. So we need to all come to a consensus on which way is going to be positive and which way is going to be negative. So what do y'all want? That's just like math, right? So in math, positive is this way and negative is this way. Are we okay with that? I know. So I am automatically flipping everything over. So in my brain, Mr. Broadway is flipping everything for you guys. So I will say that this way is positive, and I will say that this way is negative. If I come over here, I'm not going to flip it over like this. I'll say positive is this way, and I'll say negative is that way. Fair? Okay, so whenever we write them out, I'm always going to write positive in this direction and then negative in that direction. Okay? Now, up and down, which way is positive, which way is negative? Okay, up is positive, down is negative. Everybody's okay with that, right? Okay, in AP Physics, you can work the problem backwards and still be right. Okay, so like if you say that up is that way, you can still get the right answer. Okay, so like if you make that positive and you make this negative, when you actually work it out, it comes out correct, and that boggles my brain. Okay, so we're all going to do the same thing. Up is positive, down is negative, and then to the right is positive and to the left is negative. Okay, fair? Okay, I would very much appreciate that when we work on that on our practice problems, that we do that, or at least consciously try to do that. Because if I'm in the middle of grading something and I look through a problem and the entire problem is flipped over and you get the answer right, I have to look at that and make sure that you weren't just lucky. Okay, because I mean there is a chance that you could just do the problem and then be lucky and be like, oh, okay, that's a thing. Speed, we talked about, has, it's how fast you're going, but it doesn't have a negative number to it. Velocity can be negative because velocity is basically just a speed and a direction put together. Okay, so the difference between speed and velocity is that velocity is speed with a direction. Okay, which means that the same rules apply. If I'm moving this direction, let's say that we have a car, a little sombrero car. Okay, and the sombrero car is moving at 20 meters per second. I would consider this a positive number because it's moving to the right. But if my sombrero car was moving in the left direction, that would be negative 20 meters per second. Okay, and both of these are valid velocities. So the positive and the negative just really tells me which direction that we're going whenever we start the problem. Okay? Does that make sense? Is that a reasonable rule? Okay, yeah. So if you're drawing a picture and you write 20 meters per second and the arrow going this way, I will assume that that is negative. In your calculations, I will be looking to see if that's a negative number in your calculations. Does that make sense? So yeah, if you draw a picture, I'm not going to like go crazy if you don't write negative there, because if you understand that it's going that way. But my recommendation would be to go ahead and do it because it keeps you less confused. Because if you accidentally consider it positive, then everything's going to mess up in the problem, and it might not work out so well. Or you could, keep up with it and be just fine. I don't know. It really depends on how you work. I'm going to try to go for best practices, which is the stuff that I've learned from teaching physics for years of my life. But that doesn't mean you necessarily have to follow them. You know what I mean? So if you do something and you do you, uh, and it works for you, then do it. That's fine. I've seen many different ways that people solve physics problems. Um, and I don't necessarily. I'm not going to force you to do it my way. I think is the best way to say it. So yeah, I think that's perfectly fine. Now, there are some other things that we're going to use as well, but we're mainly just going to talk about the units for them because the units are what we need for the dimensional analysis. Um, we know that velocity and speed are measured in meters per second, but one of the things that we didn't talk about was force, and I think this is the only other one that actually shows up on the practice problems. And force is something that we should remember from physical science. Uh, what is a force? All right, so we can talk about either a force as a push or a pull, and we'll go into more detail about that later because we've got an entire chapter on forces. Now, what is the units for force? Okay, newtons. That's the metric system, which is what we're going to use in AP Physics. Oops, that's not possessive. Sorry, newtons. Um, in the imperial system, it's what? We measure force in. Okay. All right. Let me see. There we go. Force is measured in pounds. Absolutely. Force is measured in pounds. So when you talk about how much you weigh, you're actually talking about your gravitational pull of you from the earth to you. Okay? That's what how much you weigh, and that many pounds is how much you actually weigh. Okay? Now, we can break that down because um, a newton is not really kms, right? But it is because Newton's second law from physical science says that F equals mass times acceleration. And if that's the first time you've seen that, I am so sorry. But if you're going to talk about a force on something, it's going to depend on how big the object is, how massive the object is, and how quickly you can accelerate it. So if you can accelerate it really quickly and speed it up quickly, it's going to take a large force to be able to do that. But let's take a look at the units, okay? I guess we do need to talk about acceleration. I did not put that up there, and we'll get there soon. The mass is measured in kilograms, okay? And acceleration is measured in meters per second squared. Everything in there is kms, kilograms, meters, seconds, okay? Kilograms, meters, seconds. So the big thing is that all of these formulas that we're going to be looking for have to actually work out to be consistent in kilograms, meters, and seconds. So force measured in newtons comes out to a unit of kilogram meters per second squared. That is the same thing as multiplying a mass times an acceleration, the mass being kilograms and the acceleration being meters per second squared. Okay? Does that make sense? Are y'all okay with that? Is there any other way that you can get force? Yeah, there is. Um, but we'll worry about that one later. Um, I think that's going to show up as a practice problem, and I think whenever we get there, I'll be like, look at this. So I don't want to spoil the fun for us here in just a second. I guess we do need to talk about acceleration. What's the difference between speed and acceleration? How fast you're going fast? That's true. Yeah. So if people are going to call forces push or pulls, accelerations will either be speed ups or slow downs. Okay. Now this is a little bit of a nitpick for me, but there is technically no such thing as deceleration. Okay. Because if we talk about acceleration, that's talking about things speeding up, right? Okay. In physics, we're going to have to train our brains because I don't really use the word deceleration. And the reason I do that is because in physics, acceleration is either positive or negative. And a negative acceleration could actually mean that you're speeding up. Okay, so I don't want you to automatically think of the word negative as deceleration because that's simply not true. Okay, and case in point, which way does gravity point? Gravity sucks, right? Okay, so if you took a object and you were to take let's say a ball, and you throw the ball off of a cliff, right? Are you speeding up or slowing down? Okay, you are speeding up, right? What direction are we going? So we are speeding up in the negative direction, right? That means what we have here is we have a negative acceleration. That's right. Okay, because if you are moving in a positive direction and you get a negative acceleration, you slow down. If you get a positive acceleration in the positive direction, you speed up. Okay, so if the signs oppose each other, you slow down. If the signs are similar to each other, you actually end up speeding up. Okay, so if you're going in the negative direction and you get a negative acceleration, you're going to speed up in the negative direction. Okay, if you get a positive acceleration and you are moving in the positive direction, you're going to speed up in the positive direction. If you are moving in the positive direction and you get a negative acceleration, you're going to slow down. Okay, and then eventually you'll stop. Okay, if they keep putting that acceleration on you, and then you'll eventually start going this way. Okay, if you're going in the negative direction and you receive a positive acceleration, I just did my arm motions backward. I'm sorry. Okay, if you receive I got to think about this. Everything's backwards. Um, if you receive a positive acceleration and you're going in the negative direction, you're going to slow down, okay, because the signs are opposed to each other. Okay, positive direction, negative acceleration, slow down. Okay, so I'm never going to use the word decelerate. Okay, that word in AP Physics does not exist. In engineering, you can use that word all the time and it's fine. I'll be perfectly okay with that. But in AP Physics, the word deceleration does not exist. I will not use it. Okay. So if you say the object is decelerating, I'm going to say, I don't know what that means. Okay. I'm going to be like, I don't know. I don't know what you're talking about. And I'm going to make you say accelerate in the positive direction or accelerate in the negative direction because it does make a difference. Okay. And since we talked about how fast we're moving or how fast we're speeding up, that means that the acceleration. Does anybody know the formula for acceleration? Okay, yeah, the unit it is okay. So there are two things. Both said. I think everything was covered there pretty much. Velocity over time is the formula for acceleration, but it's measured in meters per second for velocity per second. So we don't like to write meters per second per second. So what we do instead is we write that as meters per second squared, which when you're typing it in Canvas is really hard to do. So when you're typing it out, what you'll do is you'll write meters slash s caret 2. Okay, so if you write m divided by s and then the little exponent button 2, I know you're talking about meters per second squared. Okay, or if you just literally type out meters per second squared, I'm like, yeah, I know what we're talking about. But you don't have to, you can write it shorthand this way, and that's how they used to do it in the old typewriters. Okay, so between all of these, the units for our formulas should actually be able to match up on the left side and the right side. So if I were to give you guys a formula, we should actually be able to do said formula. Okay. You'll probably want a couple of examples of how to do this first before I kind of give you guys some practice problems to do. I think that would probably be a good thing to try to talk about in terms of dimensional analysis. So I think I'm going to write this up here too. Um, all the units have to be the same on both sides of an equation. Okay, units must be the same on both sides of an equation. And it sounds like a no duh, but it's really hard to keep in mind when you're working through the math. Okay, so I'm going to give us some physics formulas, and those physics formulas have to actually work out. And let's take an example from the AP Physics formula sheet, which is something that you'll have the ability to reference on Canvas as soon as I get it up there. But if you don't have it immediately, you can always just type in AP Physics formula sheet, and it's the first thing that shows up. They give you guys this on the AP test, so it's fair game. And there's a bunch of stuff up there that doesn't make a whole lot of sense right now. Blah, 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 blah. Oh, hey, look, here's some formulas. Momentum has a P because not a whole lot of people necessarily know, or not it's not a whole bunch. There's a debate over. Some people are like they just named it that because, and some people say that momentum is because of the Latin word for motion or moving, which is poder. Okay, so since it starts with a P, they're like, oh, we're going to name it that. And then other people are like, y'all are dumb. Why would you even say that? So I don't know. There's a debate. You can go with either way. You can just say that they called it P because they're crazy or whatnot. All right. So there's a couple of things that we're going to be looking at here. Specifically, let's look at the one that says AC equals V squared over R. So I'm going to look at this one. This one looks interesting. What do you think A means? Acceleration, right? What do you think V means? Velocity. What do you think R means? Hmm. Radius, yeah. Okay, and if so, like this is a good one to kind of reference back to because if you're like, I really don't know what that is, you can look up here and you can see if you can find the letters because they should have actually put them all up here. Is that one actually on there? There it is. Yeah, radius. Okay. So we know that this is acceleration is going to be equal to the velocity squared divided by the radius. And what I want to find out is, does that actually work or are they lying to us? So we're going to write out AC equals V squared over R. We're going to put that right here. So AC equals V squared over R. And here's how we do a dimensional analysis problem. What we're going to do is we're going to break down each variable into its units. Okay, and we have to be a little bit careful because sometimes this gets a little bit alphabet soupy. So we're going to break each variable into units. Okay, and then we're going to check for combining or canceling or canceling. Okay. And that's basically the two steps that we're going to do. Whenever we combine and cancel everything out, then we should end up getting the same units on both sides. So acceleration, what is that measured in? Okay, so we're going to write meters per second squared. On the other side, we're going to write our velocity, which is, and this is where we have to be careful because it's the velocity squared. So I'm going to put parentheses around my velocity and I'm going to square everything inside there. So velocity is measured in speed. Speed's measured in distance over time, meters over seconds, right? Meters per second in parentheses squared. And then radius, which is how far away is something is in a circle, is measured in distance, and distance would be meters, okay? All right. Now, these immediately don't look like they're the same on the both sides, but there's a lot of stuff that we can cancel, and there's a lot of stuff that we can combine on the right side. And that's what we're going to do. We're going to cancel and we're going to combine on the right side. So I'm just going to leave this side over here the same. And there's a couple of different things. Well, no, I think there's only one thing I can do at the moment. I can't cancel out the m's at the very beginning because one of them's in parentheses and the other one is not. So according to the laws of math, I can't just like cancel those out yet unless you're clever pants. And I'm not. So what's up? So you want to just like have this as m squared, and if you cross multiply it over here, you're going to get an m squared, right? So I don't. So you'll get m squared over here, and then you'll get m squared over there, and then I don't. Which if you do that, mathematically speaking, if you cross multiply everything over, everything cancels out, and you get 1 = 1. Okay, and that will happen with every single physics equation that actually works, period. So, and I can see that from here because if I move the m over, you get m squared and m squared on the right side, and then you get s squared on the bottom of both sides. So you cross multiply those and you get 1 = 1. So what you want to do is try not to cross units across the equal sign. Okay, because if you do, you'll get 1 = 1. Okay, so we want to avoid 1 = 1, which is a completely and totally true statement. 1 is indeed equal to 1, but it's not an entirely helpful statement. Um, so you can make that argument with any number, but uh, okay, so there are two exponents up here that I can make m squared and I can make s squared. So I'm going to make this meters squared over second squared divided by meters over 1. Because the m is really just like part of a fraction. So what I'm doing is I'm just making a compound fraction, which is something that you may have seen in 6th grade and then completely forgotten about. How do you fix a compound fraction? Because you don't. This is not fun. We don't look at this and be like, "Yay!" You flip it and multiply, right? Yeah, we're gonna flip it and we're gonna multiply. So we're going to take this and we're going to flip it and multiply. So that's m squared over s squared equals, oh, no, sorry, times, I said multiply, times 1 over m. And we do see that some things can cancel out. There's an m on top and there's an m on bottom, which m in this case, since they're units, m stands for meters. And a lot of times people will see that m, and if I ask you quickly enough and I'm like, what does m stand for? Some people are going to go, mass. Okay, which is, if you're dealing with it as a variable, totally true. But since these are units, these are in meters. And if you have to write them all the way out at the very beginning, that'll make your life a lot easier in the long run. Okay, so one of the meters cancels out on top, and one of the meters cancels out on bottom, and you're left with meters per second squared. This works. Do what? So meters per second squared is equal to meters per second squared, right? Which is essentially 1 = 1. Yeah. So one of the ways that you can check, I just don't like us using 1 = 1 because then we don't see the units that actually end up canceling out. But we are. So, but this isn't 1 = 1. This is meters per second squared equals meters per second squared. Yeah, yeah, y'all aren't wrong. I'm not disagreeing with y'all. I'm just saying that as a physics person, I prefer to see the units rather than just the number 1 = 1. Okay? And I agree with you. You're not doing anything wrong because that one is equal to 1. If I give you an equation that doesn't work, 1 will not equal 1. You won't be able to get all of the units to cancel each other out. It won't happen. If a formula is not consistent with reality, then you can't actually get those things to cancel out. Okay? So let me give you an example. Um, so I'm going to give you a formula that is the final velocity squared is equal to the initial velocity squared plus 2 times acceleration times time. Something is wrong. Okay, this doesn't work. And I'll go ahead and I'll just tell that to you right now, is that this equation is invalid. This is not a good physics formula. Okay, this equation does not work. So let's find out and let's see what actually doesn't work about it. And if we do the dimensional analysis, you can delta t and regular t is just fine, and you do not have to use the delta. Okay, so like I know on the AP Physics formula sheet, you saw delta t a lot. Delta t just means change in time. So if you started at 0 seconds and you timed it for 5 seconds, you can just type in t equals 5. Okay, if you started at 5 seconds and you went to 10 seconds, delta t is 5. Okay, and you would calculate that by doing final minus initial, just like in math. Okay, like delta y over delta x is always y2 minus y1 over x2 minus x1. So calculating a delta t will just be t2 minus t1. So you take the later time, you subtract the earlier time, and that gives you the total distance. I hate using delta t. I just normally think about how long did it take to do that, and then I just put that in for t. Okay, if you guys like using delta t, put it in there. That's perfectly fine. I'm very flexible when it comes to that stuff. But delta t is measured in seconds, and this is also measured in seconds. There's no difference. Okay. All right. VF squared. What's velocity measured in? Meters per second. And it's squared, right? So it's going to be meters squared per second squared. So that means that everything on the right side should equal meters per second squared. And this velocity squared makes a whole lot of sense because that's just meters squared over second squared. This guy over here, the number doesn't matter. Okay, so the 2 there, nobody cares. Nobody cares at all. Okay, because the number by itself doesn't have a unit associated to it. Like if you say 2, to what, right? Exactly. So this 2 there doesn't matter. It doesn't have a unit associated to it. Okay, so I'm just going to say plus. I'm going to ignore the number completely. And I'm going to say that my acceleration is measured in meters per second squared. And my time is measured in seconds. Okay, what cancels here? That is not true. This is the same thing as s over 1. Okay, so this s can go away and this can go away, right? Okay, so you get meters squared per second squared over here plus meters per second. Now, can I add two different types of units together? No. Okay, so this doesn't work. So right here, this is an excellent indication of the big no bueno. This does not work. Okay, because you can't add two different types of units together. So you can't add an apple and an orange and say, "Well, I've got apple oranges now." It doesn't work. You can't do that. It's illegal in at least 17 states. You cannot do that. Okay? Meters per second squared on the left side would have to be meters per second squared on the right side. Now, if I use the right equation, which is one that is actually physically appropriate, and we do VF squared, this is one of the equations that we're going to have to learn. VF squared equals VI squared plus 2AD. This actually does work. And I'm going to make that an I. That kind of looked like a weird smiley face there. So this is meters squared per second squared. That didn't change. Neither did this. This is also meters squared per second squared. Plus the 2, nobody cares. Who cares? A, meters per second squared. D, meters. And this is really m over 1, right? Okay. Dot. So then you get meters squared per second squared equals, and you get meters per second, or meters squared over second squared, plus meters squared over second squared. Well, these are both the same unit, so I can add those together, and it's perfectly fine. So this is okay. And if you want to make yourself feel better at the end, you can put meters squared per second squared equals meters squared per second squared. Okay? Now, it's really important to remember that whenever I'm doing this, I'm ignoring numbers because I know that there are probably at least 2 of you in this room. I don't know who you are, but there are probably 2 of you in this room that were like, wait, if this is 1 and this is 1, shouldn't that be 2? And the answer is yeah, if you're going to add two different things together, it will come out to something, but I am ignoring the numbers and I'm ignoring any quantities that could even be existing in this particular location. And this is why people hate dimensional analysis, is because I'm ignoring the numbers. I'm just being interested in the units that are there and getting down to the meters and the seconds and the kilograms, KMS. Okay, that's correct. Okay, and so I'm worried about the units right now, and what'll happen later on is that the numbers will actually be equal to each other. So if it says, 15, we don't solve equations to say that 15 equals 15. In physics, we're going to be solving equations because we have all of this information except for one of them, and we're going to be solving for that. Okay. Usually, when it comes to physics, in reality, so like the final velocity and the initial velocity, I need to hang on. This is a bad equation. Don't pay attention to that. This one's bad. Okay, this one over here, this one's good. The final velocity and the initial velocity can usually be found with some degree of sanity because you can use either a speed gun or a stopwatch and you can calculate distance over time. So those are usually pretty easy to calculate. So is the distance. So we can normally find out how far something traveled by just using a meter stick. Okay, but the acceleration, that one is not as easy to find by using, like, what are you going to use? Your acceleration meter? If you have an acceleration meter, please show me what your acceleration meter looks like because I don't know of one that exists in terms of like finding the acceleration of an object just moving down the road. Okay? Does that make sense? So in physics, what like, if we're doing these lab based, we're usually going to be finding the acceleration using these formulas. If we have the acceleration, we'll be using them to either find the velocity or the distance, one or the other. Okay? So the rules of math still apply. We have to have all of these except for one in order to solve for the last one. Okay? And the reason that we write these equations out is because most of the variables are easy to find in real life except for one of them, and we're using those formulas to find the hard variable. Okay? Y'all want another one, or is your brain full? The brain is full. I'm gonna let y'all try this one. Um, why don't? Let's see here. Why don't we try this one? That one says, "Do you want me to write it the AP Physics way, or you want me to write it my way?" Okay, we did it my way. That's fine. That's a song too. Or maybe it's I did it my way. I don't know. So here's another equation. Yep. So D equals initial velocity times time plus 1/2 a t squared. So what I want y'all to do is I want y'all to take a moment, try to find this one by moving the units. D is what? Distance. Okay. VI is velocity, so meters per second. And acceleration is meters over second squared. And time is seconds. Okay, so we know all the basic units. Try it out. So get it one on one side, break apart the units, and let's take, I don't know, about 4 or 5 minutes and like write it out. You probably do want to write this one on a piece of paper. And if you need a piece of paper, I've got like grid paper up there on the battle station up there. You're more than welcome to grab any. And we'll take a moment to actually try to figure this one out. And my digital people, y'all probably want to do this one too. Just try it out just to see. It's good practice. This one is t squared. Yeah, so the one at the very end is times squared. That one does work. And I will go ahead and tell y'all, this was off the formula sheet, so this one should work. This one shouldn't be bogus. If it is, we have a really big problem. Yeah. Turns out that they've been lying to us for the entire years. Like, oh, I figured out why everybody did bad. The equation was wrong. Uh-oh. This is why people did so bad. But that's okay. It's easy to fix. All you got to do is just look at the dimensional analysis. Easier said than done sometimes. I wasn't trying to be mean to y'all. Yep. That does it. Write the units out for each part. And then see what cancels. Because there should be some stuff that cancels out. Yep. So this is on top. This is on bottom. These are going to cancel. And don't forget your time here. So this is meters per second. This time magically vanished. So put your seconds down here too. It's meters per second times seconds. No, not squared. So meters per second times seconds comes out just meters. Write it out. Write it out. Meters per second times seconds over 1, and the seconds will cancel out. What's up? You want me to check? Yeah, reasonable. That works. That does work. Does it work? Yes, it does. Don't forget that if they add together, then you're good to go. You are missing something. It looks like you have, okay, magic. So meters, this doesn't need to be squared up on top because velocity is just meters per second. So this is meters per second times seconds. These should cancel out. Okay, get rid of that squared too, because this is just velocity. This is meters per second. So meters per second. So then that means that these seconds should just go away completely. Yep, that's right. And then you get m over 1 equals m over 1 plus m over 1, and everybody's good. All right, I think most of y'all got it. So I'm going to write it up here. All right, am I out of time? I think I'm still good. This is meters. This is meters per second. This is seconds. Plus 1/2. Nobody cares about that. Meters per second squared times second squared. The seconds on the first one end up canceling out. The seconds on the second one end up canceling out. And I think we are now ready for our first homework assignment. Yes, it is official. It has happened. So, what you guys, I put it there, I think it's on Canvas. So, if you go to Canvas and you check out the assignments, I think I already have it up there, but I may not. So I'm double checking for you. And I can go ahead and just put them up here on the board. Assignments. There are no assignments. Okay, well I'm gonna turn on 1.1 practice problems. You should now have it. And it should say 1.1 homework.pdf. And I think it should load up for you guys. I've had to download it, but okay. The ones that I'm really worried about are the ones kind of towards the bottom where it's 1, 2, 3, 4, 5, 6, 7, 8, 9, where it says which of the following equations are dimensionally correct. These are the ones that I really want us to try to aim for. These top ones are, you can kind of, it's basically a unit conversion problem, and we can try to talk about those. But the ones that are really going to be important are these down here, to be able to check and make sure that these equations down here are actually dimensionally correct. These things right here, these number 6, 7, 8, 9, and 10 at the top, these are basically dimension word problems. Okay, so um, dealing with volume and area and some basic conversions. So if you guys do have some issues on those, we can talk about those tomorrow. But I think we get out of here at like 11:04, right? Okay, so we don't have a whole lot of time to go through these, but these are going to be the ones that I'm going to want you guys to do, and that's what y'all are going to need to turn in. You can work on these together. You can ask questions to each other. You can ask me. Once we get like comfortable with this, we'll move on to the next part. But you're going to have to give me some kind of evidence in Canvas that you actually did it. So you can do it out on paper, take a picture of it, and turn it in. That's perfectly fine. You can, if you hate writing stuff down, you can actually record yourself talking and you can talk about how you would solve every problem. I would totally take that. I would listen to you. Um, that's perfectly fine. It doesn't bother me. I kept it open to where you should have a lot of different options. If you want to type it on a Google Doc and write it out, you can do the best you can, and it should work. If you just explain every step, I'm fine with. Well, not just explain these steps that you did. You don't have to be like I did this and then divided by two and then just give me the best thing that you can. I think the easiest way would be just do it on paper and then take a picture of it. It's probably the easiest way. Okay. This is just the warm up. This is the easy stuff. There should only be one page, right? Yeah, well, there's a little bit extra over here. Number 9 and number 10. I want y'all to do this whole thing. This whole thing is fair game. Fair game. And then, digital people, if you guys have questions, let us know.